In a number of board games, players' moves are decided by rolling 2 dice and summing them. In this movie, you will learn to use TinkerPlots features to simulate rolling 2 dice. Pull out a sampler. Edit the elements, making them 1, 2, and 3. To create more elements, click the Add button. Notice that TinkerPlots correctly guesses that we want to continue with this series. We added one too many, so press the minus button to remove the last element added. Now run the sampler at very slow speed to see what it does. It's randomly drawing a number, putting it up here, and then drawing a second time. That's the rolling twice part. The results of those 2 rolls are sent over to the results table where both individual rolls and the 2 rolls joined together are visible. Let's speed this up. Altogether, this sampler simulates rolling 2 dice a total of 5 times. The sampler seems to be working fine, but let's make it more closely resemble rolling 2 dice. First, change the device to a spinner. Since we are modeling rolling 2 dice, add a second spinner, dropping it just to the right of the first spinner. Instead of using the Add button to fill the new spinner with elements, click on this button to enter the range 1 through 6. Let's name the dice die A and die B. To make sure the dice are fair, the sections need to be equal. Although they appear to be equal, let's check to make sure. Click on the down arrow in the spinner and choose Show Proportion. Then make the sampler window larger to see the values. They are all the same value. You can change the values by clicking and dragging a boundary. To make them equal again, click the down arrow on the spinner and choose Equalize Angles. Now hide the proportions. Are you more likely when you roll 2 dice to get a sum of 2 or a sum of 3? To explore this question, roll the dice 40 times and look at the results. Pull out a plot so we can graph the results. We want to look at the sums of the 2 dice, but we don't have an attribute that shows that. Various attributes can be added to the results table by going to the Options menu and selecting Results Options. Check Sum of Joined Values to add the attribute Sum to the table. Graph Sum on the x-axis of the plot and fully separate the values. And stack them up. In this sample of 40 rolls, 2 rolls had a sum of 2, and 1 roll had a sum of 3. Run the sampler to look at another sample of 40 rolls. Note that as we run more samples, our axis keeps changing based on the results of that run. Let's edit the axis so that it starts at 2, even if we don't get a 2. Double-click on this end and enter 2 in the dialog box. Let's also fix the upper end at 12 and make the bin width 1. Then turn on Count to show how many 2s and 3s we're getting. Let's run it again. This time we got more 3s than 2s, and this time we got more 2s than 3s. You can see that each time you do this, the results change. It's hard at this sample size to decide whether a sum of 2 or 3 occurs more often. Let's increase the sample size from 40 to 200 to see what happens. Now we have 13 3s and only 2 2s. and 12 threes, and 4 twos. Now, it seems that most of the time there are more sums of 3 than 2, sometimes quite a bit more. To understand why, click on the Join attribute to color the values. Note that all the 2's are the same color. They all have the same value. If we click on one of them, we see that we had to get a 1 on both rolls to get a sum of 2. But notice that in the 3's column, cases have 2 colors. Click on one color and you'll notice that you get a 1 and then a 2. Click on the case of the other color and you'll see that you got a 2 and then a 1. So there are 2 ways to get a sum of 3, but only one way to get a sum of 2. If we continue to take more and more samples, we would expect to get about twice as many sums of 3 as we get sums of 2.